Hello, I am delighted to present our paper titled Video Object Segmentation-aware Video Frame Interpolation. Video frame interpolation, called VFI, is a method for interpolating intermediate frames from input frames, typically focusing on enhancing overall quality metrics, such as PSNR and SSIM. However, this bias overlooks the fact that foreground and background have different importance levels in terms of visual quality. As you can see in the illustration below, both output videos have similar PSNR values. But in the top one, the background highlighted by the blue box is slightly sharper, while in the bottom one, the foreground highlighted by the red box is a bit sharper. This suggests that the bottom video might be more suitable for real-world vision applications. In fact, when using an object segmentation model to generate output masks, it is evident that the bottom video has cleaner boundaries. To this end, our goal is to use video object segmentation, called VOS, as an auxiliary task. Focus on interpolating foreground-centric content. Here's an overview of our method, consisting of label generation and training parts. Our approach is applied only during training, so it does not depend on a specific VFI model architecture and maintains test time complexity. To perform video object segmentation, we require RGB frames and their corresponding annotated masks. However, VFI benchmark datasets only provide RGB frames, so we either utilize VOS benchmark datasets or generate annotated masks from VFI datasets. Since VOS datasets have relatively limited diversity, we use an off-the-shelf object segmentation model, DeepLab v3, to create annotated masks for training. Then, we use to input frames and the output frame generated by the VFI model to perform VOS in both forward and backward directions. The pre-generated labels M0 and M1 are used to guide which foreground objects to focus on in each direction, while MT is used to measure the loss between masks generated in both directions. Each of these losses is computed using cross-entropy. The said F be between forward and backward output masks, and ground truth is for clean boundaries, and the said by between output masks is for temporal consistency. Here are some qualitative results comparing our method with existing VFI models, specifically focusing on video object segmentation. It is evident that our approach enhances the sharpness of the foreground. For a better comparison, we also provide video results. Next, we present results comparing our method in video object tracking. Finally, here are some quantitative results. Despite similar PSNR values, our method significantly improves the PSNR performance for the foreground, and the VOS performance also improves. In video frame interpolation datasets, models applying our method demonstrate better perceptual quality. Thank you for your interest in our paper.